wood at your house. We also have a number of robot arms and excavators in various states of disrepair, but I think they can demonstrate a couple of functions on each one. If y'all would, please. So we got bucket motion here on this one that's working. This one, the arm raise and rotation works pretty good. Oscar's got this one put back together pretty well.
Thanks, Oscar.
Zoe, how's yours doing?
Okay, so I'm gonna show. Okay, my name is Zoe, and I'm in 5th grade, and I will show y'all how this moves. So.
Sophia, open that bleeder valve, please.
So this one, it moves this up.
There we go.
And then the second one moves the arm.
So we got arm motion there.
Oh, that's good.
And then the third one moves the claw.
Boom rate. Oh no, that's the bucket. Okay.
Yeah.
So, and as Sophia demonstrated a moment ago, sometimes when you build up too much pressure in these, especially with these syringe hydraulics, you let a little bit of the magic water escape. But don't worry, that's just water with a little bit of food coloring in it. So hopefully we don't stain anything.
Computer engineering major at North Carolina State. I also work at John Deere part-time as an embedded software engineer. And so I was in charge of the snap circuit section, right? And so there's a lot of things you can do with circuitry. So I let everyone go and do their own thing. So first we got, where you from, Macy?
I was born in Iowa, but my family's from Maryland.
I'm from Maryland.
And I made this makes sounds and it has a fan.
Okay.
And you just connect the battery.
Ooh, that was a neat little trick. They want to see you do it again over there. Ooh.
What's something that was challenging, Macy?
And it was a little difficult to connect the fan to be able to work.
Right now. Go ahead.
Okay, so if you would put it somewhere else, it wouldn't work very well because the energy would not travel to it correctly. But being next to the battery makes it fly up when you take the battery off.
Awesome. Awesome. Thank you.
Next.
And what we got over here?
It's like a music box.
A music box, okay. Let's hear it. Awesome. Hopefully someone's got a birthday. We gotta have birthday party. And what we got back there?
The speaker's not really working.
Okay. It's supposed to be making a noise?
Yeah, but it's not supposed to make two noises.
Oh yeah, y'all might have to troubleshoot it a little bit and diagnose it.
The truth of engineering is it doesn't always work.
Yeah. What was it supposed to do? Just play a tune?
It's supposed to play the red and the blue. The blue makes the birthday, and the red makes the
An alarm.
alarm system.
Okay.
I think it's supposed to sound like a birthday alarm.
To have them move around, and there were like two sections where the first one was like they were going through a maze, and they have little cameras. This is a little camera, and it can sense the color. So they put this black tape down and programmed it that when it saw the tape that it would swerve around. And I think the most useful thing I learned that I didn't know already was to turn them, since these wheels can't actually like move back and forth like this. you have to have one going backwards and one going forwards. And we got to program it on the computer, and one of them, you can put a little extra marker, and there's a whiteboard, and it can draw stuff.
Anything else you want to ask, Selena?
I honestly thought like the maze thing was really cool. So, like you just had to, like type in like not really type, but like
The maze was cool. So y'all did a maze.
you had like little blocks, and they were like specific functions
Okay.
connected to the robots, and then the robot would be at it had like a precise number, like rotation, angle,
Okay.
like
All right. And then also too, I added that some people came in last night to build these because they weren't together. So a few hours had to go into actually assembling these so they could go ahead and do the programming portion of it today. Anything else y'all want to add? Did you like it? Yeah. It was fun. You would do it again?
Go left 90 degrees, so what's 90 degrees on the other one? Perfect. Alright, you ready? Oh, perfect. We don't want to go too fast. We always have to slow down. Okay. Stop it. Then ready?
So the 3D printer, you first have to code it on the computer first, and we actually made a little 3D print, tiny thing.
What do we do?
We first put shapes together, and we planned it out, and then after that we had to put it on a slicing software, so it could go onto the 3D printer, and then the 3D printer it starts heating up and stuff, and then it has to get ready to start printing, and then it starts by going by layers to make the shape, and it turns out like this, and you can just see the layers, and so it goes around and around.
Show everybody the rocket ship.
Okay, this is the next.
All right, so it's kind of small, but y'all can see it. They made a little rocket. Yep. We might have to put y'all to work. Y'all might put Bowen out of work one day. They might need your help. Okay. All right. What else did y'all make over here?
Man, we printed.
I see some other stuff over here too.
Oh, there's many things over here.
Looks like they got some little
Demos of
key fobs. They in business over here. We're in business. $5 a piece.
We got hardware. We got TV mounts, home floor layouts.
Yeah.
That's what we're working with over here. Team 6.
All right. And Winston and Dallas, introduce yourselves.
Oh, I'm Winston Griffin. I work at John Deere Turf Care. I'm the OFP buyer, so current product buyer for metal fab machines and castings.
Cool. Hey everybody, my name is B. Alex Thomas. I currently work here at this John Deere office here. I am in the engineering development program here. And yeah, I work as a mechanical engineer and went to NC State for undergrad.
Awesome. All right.
With the A&T. Aggie Pride.
Was there anybody else over here that wanted to chime in on 3D printing? I thought there was another person. Who was it?
One thing I learned maybe?
Go ahead. Yeah, I think somebody else wanted to say. Did you want to? Was it you? No. Okay.
Somebody.
All right. Go ahead. You want to say something else?
No, but is there anything else that you guys learned that you want to call out?
I mean, you learn that, for the glass, before you, put, so you have to put glue in the glass.
Glue in the glass? Okay.
It's so slippery, so it's gonna, not be perfect if you don't, put something on it so it can have, an adhesive. And then the board has to heat up as well as that. Both of them have to heat up, so first this heats up, and then this heats up, so that the thing can stick and the printer doesn't push it over and mess it up.
Awesome. Now, how is this technology useful to society? I know you said you had done the Helping Hand project, Charlie.
Oh yeah.
Tell everybody about the Helping Hand project. Does everybody know what that is? Helping Hand project? Mama said speak up. And she probably wants you to look that way.
Okay, so the Helping Hand is a non-profit business that makes hands out of 3D printing for kids that don't have hands, and so they make joints and stuff for kids that don't have fingers and stuff,
hand. And I met some of the people and they showed me some of the hands. And that's pretty cool. And that you can like size it however you want. And it's cool.
Awesome. All right, so this is how you can use engineering for good. Like they have some chapters at the different colleges that are doing that, and but yeah, great example of how you can use this technology. All right, let's give this group a hand. Thank you, middle schoolers. Thank you, Winston and the Alex. All right, high schoolers.